All right, let's learn about exponential word problems, exponential applications. There's two types. There's an exponential growth and exponential decay. This video is going to talk about exponential growth. The formula for it is going to be A is equal to P times 1 plus R raised to the T. Let's talk about what those letters mean. I'm going to write on the side of our paper, so I'm going to rotate our paper here. So again, we have A equals P times 1 plus R raised to the T. Okay, so the A stands for an account. An account balance, so it's the total amount. Oftentimes, this is what we will be solving for. The P stands for principal. It's an initial amount. How much are we starting with? An initial amount. The R stands for rate. And that rate is given as a percentage. You must change it to a decimal. T stands for time or time passed. We can also exchange that letter T for a letter X. Okay, both are going to be interchangeable. You'll see both appear the most often. We can also replace A with a Y value, so it looks more like a function that we would graph. So let's look at some of these examples here. So first, let's practice breaking down some word problems. So here, given the equation y equals 50 times 1.75 raised to the x, is this a growth or a decay? Well, if we look at our base, if we look at our parent function, this is a growth. 1.75 is bigger than 1. So we have a growth. So what is the rate of our growth? Remember from the previous video, your rate is a difference from 1. So that's going to be 0.75, or we can think of it as 75%. Your initial value, that's what's sitting in that P spot. It's going to be 15. And then it says evaluate for when x equals 4. Well, if we see the word evaluate, that means that we want to substitute and solve. So that's an x equals. I'm going to put a 4 in that x spot. And I'm going to put a 4 there. 15 times 1.75 raised to 4. Yep. All right, so that's going to give us 140.68. We'll think of it as money. A lot of these exponential growth and decay functions are dealing with the appreciation or depreciation of money. So let's look at another example. Here's our parent function. So we have a growth. That base is bigger than 1. So we're looking at the growth, and we want the rate of that growth. Well, the rate of that growth is 0.23, or 23%. The initial value is in that P spot, that principal, 25. And again, if I'm evaluating, I'm going to substitute 2 into the x spot. So 25 times 1.23 raised to the second. Oops. 2. This gives us 37.82. Go ahead and pause the video and try that third example and resume it to check your answer. Alright, now that you've resumed the video, go ahead and check your answer to see if our answers match up together. Be sure to message me on the Remind if you have any questions or you're confused about things. Let's actually work on a word problem now. Let's write our own equation. So the tuition of a private college was $15,000. The tuition has about a 7.2% increase. Write an exponential equation describing this situation. So the first number I come to is 15,000. That's the principal. That's our initial amount. That's what school initially cost. Then we're going to get into this 7.2%. Well, that's our rate, but we have to change it to a decimal. Remember, to change it to a decimal, we move it 2 places to the left. So 0.072 is going to be our rate. We then see this word increase. Increase, when we mix up these word problems, allows us to know that this is a growth function. So let's substitute it into this equation here. So we're going to have A equals, we'll always have parentheses, 1, close them. So our initial amount goes here, that's 15,000. 1, we discussed it's an increase, so that's plus our rate, so 0.072, and that's raised to the x, or to the time t, because we don't know what that is. We're just writing an equation for now. How much will the tuition be 5 years from now? Well, let's substitute a 5 into our equation. So we're going to say 15,000 times 1 plus 0.072 raised to the 5th. That's going to give us $21,235.63. Remember to round to the hundredth place because that's like rounding to the nearest penny. For money. So make sure you're rounding to that hundredth place. Let's try another example. A vintage radio was purchased by Grandma Schmidt in 1945 for $16. 16 is going to be our principal. You want your radio now? What it's worth? I'm missing some words here. Each year the radio's values increased for 1.4%. So again, that word increased tells me I have a growth function. I have my rate here, but we have to change that to a decimal. So 1, 2, so 0.014. So let's write our equation. We're going to have A is equal to, we'll always have that 1, and we'll have that time t, or you could put x. The initial amount was $16. We know we're going to have a plus for that word increased. I'm going to put my rate, 0.014. And they want to know what the radio will be worth in 2020. Well, I need to figure out how much time has passed. We knew the amount in 1945. We're going to have to figure out how much time has passed. So 2020 minus 1945, that is 75. So 75 years. So let's put that in our calculator here. We're going to have 16 times 1 plus 0.014 raised to the 75th power. My radio is only going to be worth $45.39. It's not a really great rate of increase, okay, for 75 years. All right, let's look at another example. Ben made $2,000 last summer. So 2,000, that's a principal. He wants to continue this business in the following years. He hopes that his profit will increase 10%. So again, that word increase is telling us that we want to grow. 10% is our rate, but we have to change that to a decimal, so 0.10. So let's write an equation. A equals 1. We raise it to time x. So our initial amount is $2,000. We saw that word increase, so we add. We're adding our rate of 10%, but make sure you put in the decimal. And now we want to know how much his business will have after year 7. So we're going to say, let's see, 2,000 times 1 plus 0.10 raised to the 7th power. 3,087.93. That's how much he'll make in 7 years. All right, there's one more example on the back. Go ahead and cross out 8 and 9. I'm not worried about those problems. Why don't you go ahead and practice number 7, pause the video, and come back and see how well you did. Now that you've resumed your video, here's that final answer. Double check to see how you did. Don't forget to ask questions on the remind. And tune in to the next video to learn about exponential decay.